Welcome everyone. How are you all? I hope you are doing good. And our today's new concepts are specific heat capacity and heat exchange. And these concepts are from lesson heat, and this is part 4 video of this lesson. So student, all the part 3 video of this lesson are there in my playlist, and you can also check the description box for all the links for class 10th SSC. So let's study. Okay, so first let's study about specific heat capacity. So what is it? Alright, so specific heat capacity is the amount of a heat energy. Okay, this is amount of a heat energy required to raise means required to increase the temperature of a substance per unit mass. It means when we are heating particular substance, the temperature required to increase the temperature of a substance per unit of mass, this is called as a specific heat capacity. Alright, now let's understand one activity which is given in textbook page number 68. So here we have the specific heat capacity of the metal. So different metals are there. We have used here iron metal, copper metal and lead. Alright, so now let's see the material required for this activity. A tray with thick layer of wax, solid spheres of iron, lead and copper of equal mass. That means the sphere of mass of the three or weight of the three metal sphere should be equal. Burner or a spirit lamp to provide the heat, and large beaker in which water will be there. Now let's see the procedure. So take 3 spheres of iron, copper and lead of equal mass and put all the 3 spheres in boiling water in the beaker for some time. We have to put all the 3 spheres of metal in the boiling water for some time, and take the 3 sphere out of the water. That means when the water will be heated properly or certain temperature, we should take out the 3 spheres of metal from water, and all the sphere will be at temperature 100 degrees Celsius. It means temperature of the boiling water should be 100 degrees Celsius, and put them immediately on the thick slab of a wax. And note after keeping all the 3 spheres in a wax tray, we should note the depth that each of the sphere goes into the wax. Now let's understand the observations. Alright, so the sphere which absorbs more heat from the water will give more heat to wax, and more wax will thus melt, and the sphere will go deeper in the wax. That means the sphere of a metal which will absorb more heat from the water, it will go deeper or deepest to the wax layer. Okay, and it can be observed that the iron sphere goes deepest into the wax, and lead sphere goes the least, and copper sphere goes to the intermediate depth, and which means that the iron absorb more heat from the water, and that's why it is going deepest into the waxed layer. And this shows that for equal rise in temperature, the 3 sphere have absorbed different amount of heat. It means the iron, copper, lead have absorbed different amount of heat from the water, and their depth are different in the wax layer. And this means that the property which determines the amount of a heat absorbed by a sphere is different for all the 3 metal sphere, and this property is called the specific heat capacity of a substance. Alright, so the amount of heat energy required to raise or increase the temperature of a unit mass of an object. Now object, that means in the previous slide we have seen the metal. Okay, so that means the object by 1 degree Celsius is called the specific heat of that object. And the specific heat capacity is denoted by the letter small c, and the SI unit of specific heat is joule per degree Celsius kilogram, and the CGS unit is calorie per gram degree Celsius. Alright, now here the specific heat capacity of different substances are given, like 8 substances are given for so the specific heat capacity in calorie per gram degree Celsius. For water it is 1, and paraffin it is 0.54 calorie per gram degree Celsius, and for calorie it is 0.52 calorie per gram degree Celsius. For aluminium it is 0.215, for iron it is 0.110, copper 0.095 calorie per gram degree Celsius, silver it is 0.056 calorie per gram degree Celsius, and for mercury it is 0.033 calorie per gram degree Celsius. So for the mercury it is very least, and for water the specific heat is high. Now if a specific heat of an object is C, so C is for the C tends for specific heat capacity, okay, of an object. So if specific heat capacity of an object is small c and the mass of the object is small m, and if the temperature of the object is raised, that means increased by delta T degree Celsius, okay. So temperature increases, here we have considered delta T degree Celsius, and the heat energy absorbed by the object is given by Q is equals to M into C into delta T, where Q is the heat energy absorbed, M is the mass of an object, C is for a specific heat, and delta T is the increase or raise in the temperature of a object. Now in the controversy we have in the same way, if specific heat of an object is C and the mass of the object is M, and if the temperature of the object is decrease, okay, so in the this case we have decrease in temperature by delta T degree Celsius, then the heat energy lost, okay. When the temperature is decreased, the heat energy will lost, but when the temperature is increased in the above case, so heat energy will be absorbed by the object will be Q is equals to MC into delta T, where again Q is the heat lost, heat energy lost, M is the mass, C is the specific heat, and delta T is the decrease in temperature. So these are the two different conditions which we have to remember. Alright, now our next topic is heat exchange. So if heat is exchanged, so here a box of heat resistance material in by which the okay, so if the system of both the object is isolated from the environment, okay, by keeping it inside a heat resistance box. Now heat resistance box means that the energy exchange takes place between the two objects only, like hot object and cold object. It will not related to the environment. So this is a resistance box or resistance material box, okay. Okay, so if heat is exchanged between a hot and cold object, the energy, the temperature of the, so here hot object and cold object are exchanging the temperature, and it will continue till the temperature of both the object will be similar or same. So the temperature of the cold object goes on increasing due to gain of energy. Now gain of energy means absorb of energy, and the temperature of the hot object goes on decreasing due to loss of energy or loss of heat, and the change in temperature continues till the temperature of both the objects attain the same value. So till attaining the same temperature, the heat exchange between two different object will be continue, and in this process the cold object gains or absorb heat energy, and the hot object loses heat energy. And if the system of both the object is isolated from that means it should be kept in resistance material box, so that the energy exchange takes place between the two objects only. Now in this situation we get the following principle. So the principle is heat energy lost by the hot object will be equal to heat energy gained by the object. Why this is equal? Because the heat exchange between two different objects will continue till the temperature attain the same value. That's why the heat energy lost by the hot object will be equal to the heat energy gained by the cold object, and this is called as principle of heat exchange. So this is the principle of heat exchange. Alright, now measurement of a specific heat, so it can be measured by the mixing method and calorimeter. So here this is a picture of a calorimeter in which you can observe the inside the metal vessel, metallic vessel, a thermometer is there. This is a stirrer to mix the reaction mixture. Okay, so the specific heat of an object can be measured using mixing method, and for this calorimeter is used. Now calorimeter is a device used to measure the amount of a heat involved in a certain physical process or chemical process. All right, and if a hot solid object, okay, so it is a hot solid object is put in the water in a calorimeter, heat exchange between the hot object and the water. Now hot object it will be metal, okay, and the water calorimeter starts. That means the heat exchange between the hot object and the water, okay, which is there in the calorimeter and calorimeter. So here the heat exchange are taking place between the three different objects. So this continues till the temperature of the solid object, water and the calorimeter become equal. So heat exchange between these three objects will be continued till the temperature becomes equal. And therefore heat lost by the solid object, that means the metallic object, is equal to the heat gained or absorbed by the water in the calorimeter plus heat absorbed or gained by the calorimeter. Okay. So whatever heat will be lost by the solid object, it will be absorbed by the water in calorimeter and calorimeter. Alright, now this is a previous slide only, that is heat lost by the solid object equals to heat gained or absorbed by the water in calorimeter plus heat absorbed or gained by the calorimeter. Okay. Now here the heat lost by the solid object, that is Q, is equals to mass of the solid object will be m, and multiply by its specific heat, that is C, multiply by decrease in its temperature, that is delta T or del T. So and similarly heat gained or absorbed by the water in calorimeter, that is Q1, is equals to mass of the water, that is m, into its specific heat, that will be C, and multiply by increase in its temperature, that is delta T. And similarly heat gained by the calorimeter, that means heat absorbed by calorimeter, Q2, is equals to mass of the calorimeter multiply by its specific heat multiply by increase in its temperature. Now heat lost by the hot object. Okay, so heat absorbed by the water in calorimeter and calorimeter, but heat lost by the hot object or hot metallic object will be equal to heat gained by calorimeter, that is Q1, plus heat gained by the water, that is Q2. So therefore Q is equals to Q2 plus Q1. And using this equation, if the specific heat of water and the calorimeter are known, the specific heat of the solid object can be calculated. So student, here we have finished this lesson. I hope you all have understood whatever I have taught in this video. Let's say thank you.